Alrighty, let's see if I can't do today's problem. Minimum moves to make array complementary. You're given an integer array nums of even length n, an integer limit. In one move, you can replace any integer from nums with another integer between 1 and limit inclusive. The array nums is complementary if all indices I, nums at I plus nums at n minus 1 minus I equals the same number. So it's basically nums at I and the number at an equally distant spot, kind of away from the end. For example, the array 1, 2, 3, 4 is complementary because for all indices I, they equal 5. 1 plus 4, 2 plus 3. Return the minimum number of moves required to make nums complementary. Limit is up to 10 to the 5th. Okay. I guess in the worst case, you can change everything to make sure that it works. Change everything to the same number. Okay. Alright, seems simple-ish enough. So the order really doesn't matter, it just is the pairings. 1, 3, 2, 4. So you change 1, 3 adds the 4, the 2 needs to change to a 2. Alternatively, you could keep the 2, 4 and have it be 6. And maybe make the 3 pair with a 3, so change the 1 to a 3. It's already complementary. Oh, sorry, I'm thinking of the wrong numbers. 2, 2, and 1, 1. So change either the 2, 2 into 1, 1s or the 1, 1s into... Yeah, so you can't make this low enough, right? 1 plus 1 is 2, so you'd have to make this 2 and 0, but 0 is not a possibility. And 2 and 2 is 4, but you can't make the 1 to a 3 because the limit's 2. That one is kind of tricky. 1, 2, 1, 2, this is already complementary. Okay. Let me think. My initial sense is count all the totals of the complementary, all the complementary totals. See what is the most common one, and see if you can't fix the other pairs to be that total. So the other pairs would have to be, one of them would have to be, or the bigger of the, no, they'd have to have a number that is smaller than the total and also within limit of the total in order for it to add to the sum. So like if this was, let's say the examples were, so I'll just say what the complementaries would be. So maybe if the complementaries were 20, 20, so that's a 40. And then 10 1030, and the limit was 5. This, no, 1030 is already adding to 40. So something like this. So this, in theory, let's say there was like 2020. Let's say there was another 2020. So in theory, you would want to add up to 40 as your complementary sum. But 10 plus 5 doesn't add up to 40, and 40 is already too big to add up to 40. But if this was something like 35, 40, then you'd add 5 to it to get 40. Or I guess 36, 37, 38, 39. That's on the first pass. Huh. Seems like it's 10 to the 5th value, so it's going to be n log n or n or O of n. O of n log n or O of n. Obviously it can't be n squared. N squared would be too slow here. What to do? So could I do that count of the total sums? So let's say these two values are a, b, and the limit is, let's say, k. So I'm trying to see if a and b, which doesn't add up to 40, can somehow still work. So what's the formula there? So it would be something like a plus it'd have to be something like 40 minus a. The absolute value of that is less than or equal to 40, right? Like the distance. No, a has to be smaller than 40. And it can't be equal to 40. So a plus k. So 40 is between a plus k and a minus k. Something like that. 40 is between a and a plus k. A less than 40 less than or equal to a plus k. So that's the formula. Or obviously b could be that too. B is less than 40 less than or equal to k. Or b less than 40 less than or equal to a plus, oh god. Or b less than 40 less than or equal to b plus k. Is there any other possibility? Assuming a and b don't add up to 40. So a is smaller than 40, but a plus k is less than or equal to 40. Can I rearrange this? So if I subtract a from the sides here, it's going to be 0 is less than 40 minus a less than or equal to k. Okay. Maybe this is simpler. 40 minus a is less than or equal to k. But also 40 minus a has to be a positive number. 40 minus a has to be a positive number. wonder if I can simplify this further. Can't subtract. Can't subtract k. Can't just add a. Can't add a. I don't think subtracting 40 helps. So the difference between the distance, or the difference between the sum that I'm trying to get to and the lower number has to be less or equal to k. I feel like this would probably be roughly, this seems like an n squared solution though. Maybe even like an n log n times n squared or plus n squared log n. Yeah, it doesn't seem very fast. Seems quite slow. 1, 2, 2, 1. Like this one in particular. So it's either going to add up to, it's going to add up to 2 or 4. We also need to do like some sort of edge case where what edge case is it going to be where all the numbers need to be changed? All the numbers have to be changed. So if maybe the numbers are 10, 20, 30, 40, no, 10, 20, 50, 70, and the limit is 1. Like in that case, I would need to change all the values to 1. Right. This is the other edge case. Man, I really thought this was going to be pretty easy. But just the fact that I need to count the frequency of certain sums is quite the chore. Like if there's, let's say, 200 pairs of numbers that add up to 10, and there's like another 10 numbers that pair up to be 20, then in theory I want to change those few pairs. But then I have to logically determine whether or not each pair of that can be changed to add up to 10 quickly, like instantly almost instantly. 1, 2. Wonder if I should just start by decomposing this into pairs. I can find a way to store the pairing relation between two values into some form that makes it easy to identify what is the range of values that this would work with. Like if 40 is within some range of values that A and B define. 40 is within some range of values that A and B define. So the values that A and B can define would be A up to A plus K and B up to B plus K. Yeah. A up to A plus K, B up to B plus K. So if I have 40 and I have K, then A has to be some number that is 40 minus K is a fixed value. 40 minus K is a fixed value. And A has to be bigger than that fixed value but less than 40. Is that possible for me to identify? Let me think. What if I, for every pair, for every total, I map it to a list of values of the pairs that add up to it? So I'll make maybe a dictionary for that. For every pair total, complementary pair total, map to list of values of those pairs, values from those pairs. Okay, so I guess I'll say n is equal to the length of nums for every index k in range n divided by 2, I guess. Guess I need to have a default dictionary here. Say p-values, pair values, default dictionary of list. Let's say a, b equals nums at k and nums at k minus 1 minus, or nums at n minus 1 minus k. Values append A, p-values append B. And then what? Then I think I need to track the most common sums, so the most common total. I think I want, let's say, some sort of sum value, so sum counts. And I think this should be tuples of frequency of the sum and the sum itself. So for every total in p-values, sum counts append tuple that is this total and the length of the list. Okay. I think this is a correct number of parentheses. Seems like there's an extra parentheses somewhere here. It's just the length of the p-values. Okay. And then I think I want to sort this in reverse order. So sum counts dot sort. And I think I'm going to try this and sort this reverse equals true. Turn 0. There should be nums probably. Is it default p-values at this total says a plus b. Whoops. This is awfully short, huh? 3, 4. Oh yeah, I guess they both add up to 3. And then there's 4, 2 of them, and then there's 2, there's 2 of them, yep. And there's 6, there's 2 that add up to 6, and there's 2 values that add up to 4. Okay, I think that's what I want, although, do I have a preference? Do I have a preference for lower values? For lower sums? Don't think so. Okay. I feel like I'd want to, at some point, sort the list of p-value, the list of the values from the pairs. So for every total and p-values, do this, and also do like p-values for this total, sort it. I think I want to do that first. for instance, if I have a certain common total, let's say 40 is the total, and there's like maybe A, B add up to some value and C, D add up to some value. I need to go through them and see if they can work. See if they can work. I get the sense that if they work, then either their first or last element in the list works. It doesn't have to be both, but the smallest or the biggest element has to work. If the smallest works, now it has to be the smallest and the middle element, or the largest and the middle element has to work. Yeah, it's like, so if there's, yeah, so let's say it's 2020, 2020, so 40 is the thing that I'm thinking about trying to get all my pairs to combine to. And let's say there's a few that combine to 60 instead, so like A, B, and C, D add up to 60, but there's a bunch of other 40s. So I'm trying to get A, B, C, D to add up to 40, but they're currently adding to 60. Then I look at the front end or the back end. I guess if it's a bigger number, then I should be looking at the small end. So if they add up to a bigger number, the average is going to be higher. So I should be looking at the small end. If they add up to a smaller number, then their average is smaller, so I should be at the upper end. So if A, B, C, D add up to like 20, then I should be looking at the top end of the values. Or if A, B, C, D add up to 30, then I should be looking at the bigger end. But if it's A, B, C add up to 100, then I should be looking at the small end. Okay. I wonder if I can consolidate. It. A, B, C, D. Wonder. A, B, C, D. So what's the formulation? Let's say A, B, C, D add up to some value x. So they're part of the same pairing list. They're the same p-value of x list. So, and let's say A is less than B, less than C, or A less than C, less than B, less than D, something like that. So the ordering is A, C, B, D. It's their formula for the largest pair sum it can be. So the the sum needs to be between, the sum has to be at least c plus 1, because c has to add 1. It can be at most c plus 1, it can be at least a plus 1. Let's meet a plus 1, c plus k, inclusive of c plus k. No, the sum has to be c plus 1 to c plus k. The lowest it can be has to be still higher than c. The lowest it can be has to be higher than c. But it can't be c plus k, right? It has to be at most a plus k. C plus 1 to a plus k. Because it can't be more than k. Higher than a. It has to be at least 1 higher than c. Or it has to be the other version of it. This has to be b plus 1 to, is it b plus 1 or is it b plus, no, it's d plus 1 and then b plus k. It has to be d plus 1. And d plus 1 has to be bigger than b plus k, or smaller than b plus k. I think those are the ranges. And then 40 has to fall within one of those ranges. And if c plus 1 is bigger than a plus k, then it just doesn't work. This never works. If a plus k is less than or equal to 40, does that guarantee that c plus 1 is smaller than 40? Not necessarily. Not necessarily. Let's say that x is less than 40 here. If x is less than 40, then I don't want to deal with the bigger numbers. I want to deal with the smaller numbers, which are a and c. No, that's not true. If x is smaller than 40, then I want to deal with the bigger numbers. So let's say x is bigger than 40. So let's say x is like 100. So if x is 100, then like a and c could be like 10, 20. It could be 40, 50, 40, 45. Yeah, it's not going to really be that easy, huh? A, B, C, D. Easy as A, C, B, D. So if it's a big number, a plus b plus c d is a big number, then the average is going to be higher. So you want to take the stuff that's lower. So you want to try to see if all the lower ones can be paired up. All the lower ones can be paired up to add up to 40. So you need to find whether the smallest one plus the smallest one plus k is bigger than 40, and c plus 1 is still smaller than 40. So c plus 1 is still, okay. I think, I wonder if there's a way to, I mean, this should be a fixed value, a plus k. And this should be a fixed value, c plus 1. C plus 1. Still feels like this might be n squared. Still feels like this might be n squared. Because if I try to do something where I go through the most common sum totals for the pairs, then I need to go through every other sum total and see if it works to be changed. But then that seems like n squared to me. Like if all the sums were different, then I'm starting with something of frequency 1, and then I see where every other pairing could possibly change to this total. Which does seem like n squared. Turn the minimum number of moves required to make the nums complementary. So I mean, is there a fast way to validate? Is there a fast way to validate? Could I do something where so So this thing and this thing. Could I put that on a heap? Could I put that on a heap? Or put that on a could I make these into tuples and then sort those tuples and see what needle can thread through all those ranges? The needle being the pointer to, or the value of the sum that would make it all work. Is that possible? Oh my god. Alright, this is enough thinking for tonight. I guess this is going to be the streak ender.